Greetings, fellow nerds. Let's talk about the derivative of inverse sine. So what I'm going to do to differentiate inverse sine, I'm going to imagine it obviously being an inverse function, right? So that being said, I'm going to use this formula then that I've derived in a previous video. Right? The weird thing about this notation, I've said this in other videos, is that little guy right there. Remember that whatever function you write here, this is the derivative of the inverse to whatever function this is. And so in our case, our inverse function is sine. So so therefore the inverse function to arcsine is just sine. So its derivative cosine is actually what's going to go right there. So here we go. Let's apply that formula, right? So again, like I said before, the derivative of the inverse function to sine is what goes right there, which is, again, cosine. And so replacing f prime with cosine, we have this. We're almost there, of course. Remember that we decided that the inverse function of f is just arcsine, so we can replace arcsine in that formula. And then what we're going to do is use the Pythagorean identity for cosine and sine. So, right, sine squared plus cosine squared is 1. I'm going to solve this equation for cosine, though. So I'm going to subtract sine squared from both sides. And then I'm going to take the square root of both sides of that equation. So what I'm going to do now is replace this cosine that you see right here with this expression for cosine. So it would look like this. So this may not look like much at first, and certainly more complicated looking than this, but there's actually something really cool here. And it actually is kind of hidden by this too. So right, remember this sine squared. What is this square squaring? Well, it's actually squaring that whole thing right there, the sine of the inverse sine of x. But again, if you look at that, what actually are you looking at? Well, you've got a function, arcsine, inside of its inverse sine. A function composite with its inverse. Well, those two undo each other, and you're left with just x. And so, the derivative of the inverse sine function is actually just 1 over the square root of 1 minus x squared. And as always, take care, nerds.